our physical science. So go ahead and get out your periodic table. Remember, that's the first thing you should do anytime you come into my class during this unit, and next unit for that matter. You should just sit down, say what's up to your partner, get out your pencil, get out your periodic table, and get ready to roll. Now, let's go over a few things that should be on your periodic table at this point. So you should have a little information about your three subatomic particles, your protons, neutrons, and electrons. Notice how protons have a charge and a mass. Neutrons only have a mass. Electrons only have a charge. Okay? So we can see why protons are part of our two equations here. So we got our charge equation highlighted here, and we have our mass equation highlighted right below that. They both involve protons, and that's why we always say protons are the most important part of the atom. They tell you exactly what element it is, and they affect the charge, and they affect the mass. So that's the very first thing we always have to get. Now, please notice on the right, we have our full atomic symbol. So that's when we summarize all the information we know about a particular atom. So let's recall, hey, A, that's talking about the mass of that particular atom. And the Z, that is the atomic number, aka simply the number of protons, okay? So that's your number of protons, if I can kind of X that out there. Number of protons, same thing. And here, we've got our charge, okay? So later on in class today, when you guys are working on problems where you have to write the full atomic symbol, those are the three pieces of information you have to have surrounding the symbol of the element itself. So there's the symbol itself. Now there is no element X, so that is just a placeholder for real element symbols like, you know, carbon, nitrogen, phosphorus, that kind of thing. Let's go ahead and take a look at our worksheet here. I have some reminders up there. They say a lot of the same things I just said. I'm going to go ahead and write out my two equations, though, because I want to use those a bunch during, actually I'm going to move that over just a little bit. Here we go. So I'm going to use these a bunch during these practice problems. So the charge of any given atom will be equal to the protons minus the electrons. And this is on your periodic table, but it never hurts to write it again on this worksheet. Mass is equal to protons plus neutrons. Okay? So let's go ahead and take a look at this first one. We're told it's carbon, it has a mass of 12, and it has 6 electrons. Again, the most important part of an atom is its number of protons. So that's the first thing we got to find out. Since it wasn't given to us, that's the first thing we got to find out. Well, this is carbon. If we look at our periodic table for a second here, carbon has an atomic number of 6. So I'm going to go ahead and write that in, atomic number of 6. Now, the number that is automatically, always and forever, the same exact thing as the atomic number is your number of protons. The atomic number is just a fancy name for the number of protons. Those are literally the same thing. So, whoopsie, I don't want to do that. I want to highlight. Your highlighter. So the atomic number and the number of protons are literally going to be the same thing for every single problem. Same thing for every single problem. Okay, so if you know one, you know the other. Okay, but now I got my number of protons, so I'm really cooking at this point. I have a question where it asks me for the neutrons. So if I want to know the neutrons, I need to use an equation to calculate that. So I need an equation that has neutrons in it, and I have all the other information that aren't about neutrons. So for example, I have the mass. Oh, again, it's highlighting when it shouldn't be. My board's crazy. I have the mass. Listen to this problem. It's 12. Stop it. Why won't you write with ink? Oh, the substitute's probably wondering if I've lost my mind. My students know that this happens every single day. Alrighty, one more try. There we go. So the mass is 12. We know that the protons are 6. We don't know what our neutrons are, but we are in business because we have 2 of the 3 parts of this equation. So what's the opposite of adding 6 to your number of neutrons? Subtracting 6. So if I subtract 6 on this side, it cancels out. But I need to do the same thing on both sides of the equation. So I'll find that 6 must be equal to my number of neutrons. So there goes my number of neutrons there. Boom. And the last thing it asked me is the full atomic symbol. So let's go over and repeat again. So we start with our symbol, which is just C for carbon in the middle. In the top left, we have the mass number, which is 12. In the bottom left, we have our atomic number, aka the number of protons, which in this case is 6. And in the top right, we have the charge. Well, our charge is going to be equal to protons minus electrons. We have 6 protons. We've got 6 electrons. So the charge is simply 0 this time. So I'm just going to put a 0 right there. No need for a positive or negative symbol, because there isn't one for this particular problem. Okay, so next thing we're going to do is we're going to skip down a couple. We're going to try this bromine problem, a couple down below that. So again, I'm not given my number of protons off the bat, so I need to go get that. Luckily, it tells me that the element is bromine, so if I come back over here, I'll find bromine on the right-hand side. Here it is, atomic number 35. Great. So that means my atomic number is 35. Automatically, I know that my number of protons is 35. And we are in business at this point. So I'm told that the number of neutrons is 40 this time. I wasn't given neutrons last problem. And I have to go find a number of electrons. Okay, well, let me go ahead and erase my work that I did for the last problem. And I'm going to go over here. Okay. So charge, we're told, is, oh, it's -1. Where are you getting that from, Mr. Pilcher? Right there. I got a charge listed in my full atomic symbol. So I'm going to have to finish up the rest of that full atomic symbol, but I am given that piece of information. So the charge is -1. I know my number of protons is equal to 35. And I'm looking for the number of electrons. So 35 minus what would make it -1? Well, that would have to be 35 minus 36. Which makes sense. If the charge is negative, that means you have to have more electrons than protons. How many more? Well, if it's -1, 1 more. So I've got 36 electrons. And now I need to fill in the rest. So if I am told that the mass, aka the A of the element, is 75, then I put that in the top left. The atomic number is 35, so that goes in the bottom left. We already have the charge listed in the top right, and the symbol's already listed for us as well, so now we are all done. We're all done. Now let's point one thing out real quick. I see that the mass of this is 75, but if I go to the periodic table, the mass is listed as 79.9, which rounds up to 80. It's like, whoa, 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 I thought bromine's mass had to be 80. Remember, this mass on the periodic table is simply an average. That's all that's telling you is that, bromines are, what I'll say, quote, usually 80. Okay? That doesn't mean all bromines have a mass of 80. That just means that's the most common mass for a bromine. Just like a lot of you in this room right now are freshmen, it's more likely than not that you are 14, since it is the first half of the school year, but some of you guys are 15. Like, I've had you raise your hands a couple of times at this point. So I could guess that bromine's mass is 80 if I don't have any other information, and that's the best number to guess. But it's often going to be a number a little bit below 80 or a little bit above 80. Now, we're not going to see a bromine with a number that's not close to that. We're not going to see a number that's like a bromine with a mass of 200, just like you're not going to see a freshman that's it's like 36 years old. Okay, that would be problematic. But that's just an average if you're using the number off the periodic table. And we only use that number if we have no other choice, okay? So let's go back over here. Let's take a look at another problem. This next one, right below bromine, that's a tricky one, okay? Because we're given the mass number is 21, the number of neutrons is 11, and the number of electrons is 10. So we have a lot of work to do. Now remember, what's the most important part of the atom? The number of protons. So that's the first thing that we got to go find, because everything flows out of that. Okay, well, how am I supposed to do that? We know that our two equations are the only things we have at our disposal. So we are looking for the equation that we have two parts of the info already, and we can go ahead and find that third part on our own. So I see a mass and the number of neutrons. So that lets me know, oh, hey, I can use this equation on the right. So I've got a mass of 21. I don't know what my protons are, but I know that I've got 11 neutrons. So if I want to get protons by itself, the opposite, or the way to undo adding by 11, is to subtract 11 on both sides. So I'll find that 10 is equal to my number of protons after these 11s cancel out. So I've got 10 protons, which means I automatically have an atomic number of 10. And what element do I have to be talking about? Going back to my periodic table, element number 10 right here. Oh, that's neon. Okay, cool. So this must be neon. Now I'll fill out the rest of my information. Looks like I just have the full atomic symbol left. The symbol for neon, as you guys should know by now, is Ne. This neon's mass is 21, which again is not the number listed on the periodic table. It's close to it. Neons are more often 20 than 21, but that's not an issue for us. Our atomic number, or the number of protons, is 10. And the charge of this neon, so I have 10 protons, which I can see here. Got 10 protons minus 10 electrons. Okay, well that's definitely just going to be 0. So I'm not going to worry about that calculation. I'm just going to go ahead and be like, all right, that's a 0. Boom, good to go. And maybe we'll try one more in here. Let's try this one for carbon. So we're down to this row right below neon. We're kind of going backwards at this point because we're given the full atomic symbol instead of working towards it, and we have to go backwards to figure out the rest of the information. So this was sort of like part 2 of our lab on Wednesday when we were using the marbles to build atoms. So I'm looking at this, I see, okay, I have the mass number, and I got the full atomic symbol, and that's all I got to work with. I'm going to scroll back up a little bit so I can still see my equations. Like, okay, well, let's remember what we're given in that full atomic symbol. We know that this number right here, that is our mass, which is 14, and we have that listed. We know that this number right here is our atomic number, so that bottom left, 6, aka the number of protons. Like, oh, okay, all right, I can see where this is going. So I've got 6 protons, and again, the atomic number and the number of protons is the same thing. That symbol in the middle, C, stands for the element carbon, as I've already mentioned here. So I'm writing carbon over here. And then the charge we're told is +4. So let's just go ahead and toss that into an equation here. So I've got a charge of +4. I know that I have 6 protons. I don't know my number of electrons, but 6 minus what equals +4? Well, we should see that 6 minus 2 equals +4. So I'm coming down here. I know my number of electrons is 2. And then I'm looking at this and it says number of neutrons, last piece of information I need. Well, I know my mass is 14, which is a little bit higher than the typical carbon of 12, but that's okay. I've got 6 protons. I don't know how many neutrons. If I subtract 6 from both sides to get neutrons by itself, so that cancels, I'll find that 8 is equal to my number of neutrons. And there we are. Okay. So I'm going to scroll down here a little bit. So I just did this carbon problem. Now I'm going to check out the zinc one. So the last problem I'm going to do here, and then you guys are working independently for the rest of the period. There's a particular reason why I picked this zinc one. So we are told, hey, so this first number 30, that represents our atomic number. The number of protons is 30, and the number of electrons is 30. So I know my atomic number, my number of protons, which, you know, that's really just the same thing. I could have told you that. Or you could have told me that. And I know the number of electrons, but that's it. So we're taking a look at this. Well, first we could find out charge pretty easily because we know the protons and electrons. We've got, I want that to be a different color. Here we go. We've got 30 protons. We've got 30 electrons. Obviously, that comes out to be a charge of 0. So I'll use that for my full atomic symbol later. Now, if I'm looking at this, I don't know mass, and I also don't know the number of neutrons. I know my protons are equal to 30, but I'm like, well, Mr. Pilcher, I can't do that problem. I have 2 missing variables. That is where we use the periodic table as our last-ditch effort. So again, these previous problems, so carbon in that last one we just did, its mass was 14, which is not usual. Carbon's mass is usually 12. Look at carbon right here. The mass is usually 12. But we would guess carbon's mass is 12 if we had no choice. And this particular problem with zinc, we don't know the neutrons, we don't know the mass, so we're just going to have to guess that's like a typical zinc. So if I am finding zinc here, here it is, atomic number 30, and its mass is listed at 65.39, which we're just going to round to the closest whole number of 65, because we don't have any other option. Like, what are we supposed to do? We have to include the mass in the full atomic symbol. So, all right, well, 65 is the best guess for zinc. Sometimes they can have a mass of 66 or 67, but 65 is the most common, so okay, I'm going to go with that. So my mass number I'm going to list as 65. There we go. And now I can find my number of neutrons, and again, this is going to be for a typical zinc. So my mass, I now know, if I go ahead and white this out there, my mass is going to be 65. I set that equal to the 30 protons plus an unknown number of neutrons. So I'll just leave that as an N because I don't know what that is. So if I subtract 30 from both sides here, I'll find that my number of neutrons is equal to 35. So the typical zinc will have 35 neutrons. And now I'm finally at my atomic symbol. So again, I start with the symbol in the middle. Zinc symbol is Zn. Careful on that. Some people want to put Zi or Zc. It's Zn. The mass in the top left-hand corner will be 65. The atomic symbol, the atomic number, aka the number of protons, will be in the bottom left, and that is 30. And my charge, which I figured out pretty early in this problem, is simply 0, so I'm just going to plop a 0 right there. So that covers all the different types of problems you might see. Now, these are a lot of problems, okay? But here's what I want. I want you to work the whole period on this. You will turn in whatever you have done, and I'm expecting you guys to have pretty much all this worksheet done by the end of the period. You have a lot of time. You're going to turn it into my substitute, okay? And I'm going to take a look at those over the weekend. So make sure your name is on it right now. So double check. Look at the top. Is your name on it? Billy Smith. Make sure you have that on top of there. And I will have the substitute collect this. I'm going to take a look at it myself this weekend, okay? If you guys have any questions, please feel free to email me. And remember, you can kind of chat with your partner next to you if you want to do a couple problems together if you get a little stuck, okay? All right, folks, you guys have a great rest of your Friday. And remember, you are working until that bell rings. I'll see you guys on Monday.